Now let's talk about how we can solve a simple minimization problem in Matlab with respect to a given, let's say, constraint. And in our examples in the slide, we have seen a simple calculus problem. Basically, we have a function with two variables, x and z. So it's x squared plus z squared, and we have a constraint, x plus z equals to 1. So this type of problems in Matlab can be solved using the fmincon function. So if you open your help file and you can type here, it will show up this fmincon function. And this function allows us to use a variety of different types of constraints, actually, not just equality, but it can also be inequalities. And we can also define some actually lower and upper bounds for the domain of our x values. So here x here is going to be actually a vector. So in this case, it's a two variable. It has two coordinates, x1 and x2. And if you look at the syntax, the first thing you need to input is the function. So we need to define this function, which is the objective function x squared plus z squared. And then after we define it, we can input the initial values to start our solver. And then we need to input a and b. So this a, b, if you don't have any inequality constraint, so this a can be a matrix and b can be a vector here. But if you don't have any inequalities as a constraint, then you can leave them empty. And then you can go to the next constraint type, which is, you can see the equality constraint, which we have. Okay, so we will use this second syntax to solve this problem. That should be sufficient in this example. So let's start with the first things first, and I have already written here to save some time. You can see that I have this simple function defined here, and it takes a vector which has two variables as an input, and x1 squared plus x2 squared, that's returned as the output of this function. So once I have this function defined, now basically we can follow the help file and try to write our function in this format here. You can see we can do some initial guess. Let's say 0 and 0. That's our initial value for x0, and we already defined our function. So now we will use fmincon, and that's going to be the function name, which is my function 1, and I have my x0, and I don't have any inequality constraints. You can follow we have to follow the same order. So this is a and b, and basically if I don't have any, I can leave them empty. So a and b is skipped. And then we have some equality constraints. So this is a equality b. And in this case, we're gonna write this as in this way. So this is gonna be multiplied by the x1 and x2, or you can think this as x and z. So this is x plus z, and the right hand side of this is simply equal to 1, right? And basically, if you don't have any other argument for the lower and upper bound, you can just stop that. And if you want to display what's the result of this, well, here you don't need to write this actually. So if we run, we can check the result. You can see that the result is 0.5 and 0.5. So you can try to solve some similar examples, and you can try it on your own.